All right, this is POTD, 26th of March, 2026. Crap. Okay. Equal sum grid partition 2. Wait. Oh, okay. I was going to say, this looks the same. You're given an m by n matrix grid of positive integers. Your task is to determine if it is possible to make either one horizontal or one vertical grid such that each of the two resulting sections is non-empty. That's the same. The sum of the both sections is equal or can be made equal by discounting at most one single cell in total. If the cell is discounted, the rest of the section must remain connected. Okay. So a section is connected if every cell in it can be reached from any other cell by moving up, down, left, or right. Why would that not happen? What? As in like, what? Oh, I understand. No, I get it. Because basically 3548. Okay. Is this on? Yeah, okay. 3548 POTD, right? Okay, so basically it's the same as yesterday's problem, except for example, let's say you have a slice here and the sum of this is like 200 and the sum of this is like, the sum of this guy is like 204, right? So the idea is if you exclude a 4, then you'd get the same size, right? But the issue is if the 4 that you cut out is over here, right? If that's the 4 that you remove in order to make the overall total 200, then these sections are disconnected. So I think it's only for if you have a section that's like a 1 by n or a n by 1 kind of size, like one row or one column, then you have to be a bit worried. Otherwise, it should be fine. So in that case, if it is like a 1 row or 1 column in this case, 1 column that you're slicing, then the only things you're allowed to remove are like the end pieces. Okay. This is quite hard. Return true if such a partition exists, and otherwise return false. So I'm assuming it's similar logic like as yesterday, where I'll try to draw it a bit straight. I always draw in a slant, I realize. I need to like turn the tablet. If I've got like, a 3x3, and like basically I can check, I can slice down these columns and check, what's the sum, and then, what's this sum versus this sum, and compare it. And then like, are they all positive numbers? That would be a good thing to check, actually. So what are my constraints? Okay, good. So every number inside the grid is positive. There's 10 to the 5 elements. Okay. So let's say, I think what we want to know quickly is, does there exist... I'm thinking about this whole removing one element thing. Because for example, let's say I make a slice like this, and the sum on the left section is 32, and the sum on the right section is 30. So these two sums obviously don't add up together, like don't equal each other, sorry. But if there was a 2 here, then I could get rid of it and I'd be left with the 30, right? So that's my understanding at least. So it's like 1, 2, so in this case here, if you have this example, 6 plus 1 makes 7, and then 2, 5, and I guess that's a 3, or 8 or something. No, it's a 3. 2, 3, 5 would make 10 originally, but you get rid of the 3, you get 7, so then it's equal. So in that kind of vein, like knowing that this adds up to 7 and this adds up to 10, the question is, okay, this is the bigger sum. Does there exist a 3 that I could remove? Oh wait, but this is false though, because you're disconnecting. So, okay, yeah, okay. But generally speaking, that's the idea. Another edge case. No, not really. It's fine. Okay, so I kind of like want a lookup on like if you've seen a particular number before. Which I feel like, considering there's no sortedness, I feel like I might need a hint. I don't know. I'll try this for a few minutes and then we'll see. Like, I feel like this kind of idea of like having a lookup to figure out if there's a 2 in this submatrix is like really going to be either time intensive, or it's going to be space intensive. Although actually, maybe not. I have an idea. Let's only focus on, okay, so again, I think I did this yesterday as well. Let's only focus on row slices, so horizontal slices for now, right? Because I think it's the same thing twice. And let's say we have an example like this. I'll give myself like a fair few rows to work with. Wait, that's too many rows. Right? Just as an idea. And then you have like 2, 3, 4, 6. 1, 2, 3, 4, 5, 8, 7, 1. Okay, what is that up to? 15, and then 7 plus 2 makes 9, 10, and then 15, 21. Okay, so these all add up to 31, 41. Is it 46? That looks right. Yep. And then I want this to add up to 46. So like, I don't know, 1, 1, 1, 1 makes 4, and then like 20, 20 makes 40, 44, 45. Wait, 20 to 43, 44, 45, 46, 47. So make that a 2. That'll get to 40. So 1 to 40, 1, 42, 43, 44, 45, 46. So the idea is I'm going to exclude. Okay, okay. This is my example, right? So the idea is I try a slice like this. I do my little row sum trick, right? 15 and, well, first I guess I'll do it properly. Hang on. So I need the eraser. Or maybe the lasso is better. No, what? Give me that. No, give me the lasso. Thank you. Alright, so we do the row-wise prefix sum. So this adds up to 15, we said, and this is individually 7 plus 10, so cumulative total is 25 because it's the 10 plus the 15, and then it's 15, 21, so plus the 25 makes 46, and then that's the 46, and then 41, 42, 43, so it's 89, and then 89, 90, 91, 92, 93. Okay, so from this computation, we know that the total sum is equal to 93. Fair enough? Okay. From there, here's what I think I would do, okay? I would somehow start with a slice that goes like this. Okay? And then I would create a set that contains all the numbers that are in this side. 2, 3, 4, and 6. Okay? Then I would do my count, 15 on this side, and then 93 minus 15, which is like 83, like 78 or something. So 78 on this side, which means the difference between these two is like 63. Which obviously isn't going to work. Okay, here's what I'll do. I won't bother like checking until I get to a point where the sum on the top side is bigger than the sum on the bottom side. Right? Or equal to, obviously. So, that slice doesn't work. That slice, I've got 25 for this total. And I've got 93 minus 25, which means 93, 73, 68, I think. So this is still smaller than this, so I won't bother checking. I slice again. Oh, but I have to keep track of all the numbers. So 1, 2, 3, 4, 2 is duplicate, 5, 8, 7, or whatever. right? So I'm keeping track of all the numbers that I've seen in the top, right? So now I've got, now I've got 46 values over here, and I've got 93, 43, 46 minus 93 makes 8, carry the 1, 7, 47. Okay. 47 for these two values. So this is still too big compared to this, so I don't care. I move on. And then I have set equals, I had like the 20, and I had like the 2, oh no, sorry, and a 1. Like, I've got a lookup table of everything on this side, okay? And then I ask, okay, there's 89 on this side, which means there's 93 minus this 4. The bottom thing adds up to 4. What? Give me the eraser, man. Thank you. The top thing adds up to 89, the bottom thing adds up to 4. So, using this slice, right? So, I ask, okay, bearing that in mind, 89 is bigger than 4. Do I have an 85 somewhere in this top segment that I can remove? And the answer is no. Looking at my set, I do not, right? Okay. And then basically my thinking is, obviously I ignored this slice when I shouldn't have. That's because I only knew what numbers are in the top segment. So I can repeat the process, except instead of slicing down, I can slice up. I can slice like up. And this time my set, instead of holding the numbers that are in the top, I hold the numbers that are in the bottom. So I double the workload by basically repeating the process, but I go in the opposite direction. And that should help me find the upward slice. And then I repeat the same thing for column slices, going along this way and then back this way. Now, is there a more efficient way that I can combine this into one go? The reason why I thought no is because, for example, let's say I'm considering this slice, the very first one, right? Then, for example, I have 2. Oh no, I could probably. No, I could. I definitely could. I don't have to go down and up. I just, instead of using sets, I use hash tables, where the key represents the number, like the value. The key represents the grid number, and the map tells, and it maps to the frequency. So I could hash table number 1 for the top segment, and hash table number 2 for the bottom segment. And every time we, so if we consider this slice, for example, it would, the top hash table would say 2, 1, 3, 1, 4, 1, 6, 1. The bottom table would say 1, and there's 1, 2, 3, 4, 5, 6, there's 7 ones. So 1 maps to 7, 2 maps to 2, 3 maps to, I think there's only 1, 3 maps to 1, 4 maps to 1, 5 maps to 1, 8 maps to 1, 7 maps to 1, 20 maps to 2, and that's it. Oh, 1, 2, 3, 4, 5, 6, yeah. So yeah, 20 maps to 2. So you have that, and every time you move the slice down, you say, okay, whatever I just introduced into the top segment in this row, I should subtract from the bottom hash table and add to the top. So now the top hash table will say 1, 1, 2, 2, 3, 3, that should increment 4, sorry, 3, 2, sorry, 3 should map to 2 because there's 2 of them, and 4 maps to 2, and 6 maps to 1. And then down here, for example, 1 will map to 6 now, 1, 2, 3, 4, 5, 6, yeah, right? So we can very carefully keep track of how many numbers and like which numbers and how many of them exist in the top and bottom segment using hash tables. Now, from there, I have to be careful about the connection thing. If the size of my segments is not 1 by something, then I don't have to worry about it, because it's like, no matter what you remove, there'll always be a way to stay connected. Like, there'll always be a route to get everything. So that's fine. But if it is a 1 by something kind of segment, and I'll do a separate example. Let's say, for example, you've got like 1, 1, 1, 1, 1, 1, 1, 1. That's 8. And then you got 2, 4, 8, 9. Right? So we contemplate the very first slice. And we go, hey, look, this one adds up to 9, this one adds up to 8, and using our hash tables, we'll say, hey, look, that guy is a 1. How fantastic. Now, there might be cleverer ways of doing this, since there's only one sort of iteration that I have to do to check where the 1 is, right? Since there's only one like loop I'd have to write, I think for a 1 by something shape, I'll just iterate through. And if the 1 exists on the ends, then that's perfectly fine. I'm allowed to delete that one. If it exists somewhere in the middle, like in this case, then it's illegal moves and I should move on and try another slice. So I think that's what I'll do. Oh, this is a little bit annoying to be honest. Not because it's, as in like, it's not difficult, but it is finicky. Conceptually it's not difficult, but practically speaking, it's just a lot to do at once. All right, so we'll say hash table top is equal to empty, hash table bottom is equal to empty. Oops, is equal to empty, right? Happy days. And then I could like take yesterday's problem and like copy and paste and try to adjust it, but I'll do it from scratch, I think, just to practice. So I don't need sets, I need hash tables. We're doing something like this. How do I want to do this? I think what I'll do is I'll initialize htbot, so numRows equals greater than 0, length of, and numcols equal to length. Wait, what am I doing? How many times have I typed this exact line last like month? 0, there you go. So I think what I'll do is I'll say for row in grid, and then for value in the row, if value, how do I do? Oh, I think that I should use the that library, like default dictionary or something. Whatever. ht bottom for this value is equal to 1 plus ht bottom dot get the value or default to 0. This kind of thing, right? So this, basically, I'm saying, pretend the first slice, or the 0th slice, is over here. So the top segment has nothing in it, and the bottom slice has everything in it, you know? And I'm keeping track of how many there are. So that's fun. For row in grid, for val in row. Okay. So then from there, what do I want to do? For r, okay, so for row slice in range 0 up to num rows minus 1, because if you've got, for example, 1, 2, 3, 4, 5 rows, you have to do 4 slices. 1, 2, 3, 4. We talked about that yesterday. So for each row slice, next row is equal to grid at the row slice, right? Like whatever that is. And we have to adjust the ht top and the ht bottom. So for value in the next row, if ht top dot the ht top add value equals 1 plus ht top dot get the value or default to 0. And I think it's safe to just say ht bottom at value minus equals 1. I think I can just say that because we initialize it such that ht bottom has all of them, has all the numbers. So I should be able to safely just subtract without too many issues. Like, I don't think this is going to be a problem. So we've adjusted the hash tables appropriately. Oh wait, I didn't do the prefix thing. Hang on, sorry. Prefix, so row prefix sum is equal to 0 for in range num rows. I could just say for in grid, can't I? Oh well, I think this is more explicit anyway. And then can I say sum of grid at I plus row prefix sum minus 1? Can I do that? It's kind of dodgy, right? Because I shouldn't do that for now. I'll just do it properly. I'll say 0, and then oops, and then I'll say for I in range num rows, if I is equal to 0, if it's the very first one, then row prefix sum at 0 is equal to just the sum of grid at 0. Else, row prefix sum at I is equal to the sum of grid at I plus the previous value that we just entered beforehand. So that gives us a row prefix sum. Sorry. And then, what was I doing? Some slicing. Alright, so, and I should say, total sum or whatever is equal to row prefix sum at the last value. This I should probably put at the top because I feel like this makes sense. Alright, so total sum is equal to that guy. You get that guy, you're slicing down, 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 the prices are down. And then, I'm a bit hungry. Wait, what am I thinking? So I'm slicing and then I need to figure out the sum. So top sum is simply the row prefix sum at the row slice, right? And then the bottom sum is equal to the total sum minus the top sum, right? So that's fine, we have that. If top sum is equal to bottom sum, then happy days, right? If elif top sum minus bottom sum is in HT top, if row slice is equal to 0, else I think you can return true. So if the difference between top sum and bottom sum, which will be positive, which, you know, if it's positive means that it's like, if top sum is bigger than bottom sum, if top sum is more than, okay, wait, let me say this properly. If top sum is smaller than bottom sum and this goes negative, then this will definitely evaluate to false because I'm not putting any negative numbers in HT top anyway, so I don't have to worry about like all negatives. Anyway, if it's positive and it's in HT top, that means that there exists a value that exists, you know, the difference, the discrepancy in the top segment, which means that's something I can delete. Now, if row slice is not 0, then that means that, you know, I've sliced somewhere that isn't just the very first slice, which means whatever I remove, the thing will stay connected. I don't have to worry about that, so I can return true, no problems. However, if it is 0, I have to find the index val. Oh, but what if it happens multiple times? Oh man, I have to find the most middleist index I can. Okay, I'll make a helper. Def find middleist index given a particular row and a particular value. Right, so num elements is equal to length of row. For I enumerate, wait, what? For I v in enumerate row, if I is equal to 0, then continue. And if I is equal to num elements minus 1, then continue. And if v equals val, then return true. No, return I, return 0. So it returns I, which will be a middle index if it finds, the value we want. Oh wait, no. I want it to equal, I want I to be one of these things. Wait a minute. So I just have to check if I don't have to do any. Why am I looping? I'm so dumb. For some reason, I got confused between whether I needed to. I thought I wanted. I don't want one in the middle. Okay. Hang on. If row slice is 0, that is we've only sliced the. If grid at row 0, like the first element, is equal to the top sum minus the bottom sum, or grid at that row and then the very last element in that row. So how many columns are there? N is equal to the discrepancy. Yeah, I don't have to loop at all. Then return true. Otherwise, you're gonna have to continue on. Alright, and then similar idea. Elif bottom sum minus top sum is in HT bottom, then if the row slice is equal to number of I guess num rows minus 2, because like 1, 2, 3, 4, 5, which means 0, 1, 2, 3. Numbers minus 2 tells you the very last slice. Yeah. If row slice is equal to 2, else you can happily return true. Otherwise, if grid at the very last row, first element is equal to bottom sum minus top sum, or grid at the very last row at the very last element is equal to bottom sum minus top sum, then we can happily return true. Otherwise, we're going to have to move on. And that is just half the problem. I apologize. Alright, let me just split this because I feel like this might use like double the space or whatever, because I'm gonna like just make them completely separate, but I just don't want to look at it. Alright, and then from there, I'm hoping that, wait, what? Oh, that's right, yeah, sorry. Okay, so HT left, what? Sorry. No, not that one. Not you. ht bot right. ht right. Okay. ht left, ht right. Num rows is that, num calls is that. For row in grid, for val in this, ht right is this there, row prefix sum. Okay, so this would be call prefix sum is for number of calls in this one. This is a problem, isn't it? Because I need to go down first. For call in range num calls, for row. Wait, no, I don't. No, I don't. It's all the values. It's all the values. It doesn't matter. Sorry, I forgot what this was for. Because this is all the values in the. That's the beauty of this. All right. So then, for this one and this one, you might have to change a little bit. So for C in range num calls, for R in range num rows, call sum is equal to 0. Call sum plus equals grid at RC. And we'll say if C is equal to 0, then call prefix sum at 0 is just equal to the call sum that was created, else call prefix sum at this particular column is equal to the call sum we just created plus whatever the previous value we saw. So hopefully that's accurate. Get rid of that. Sure, yeah. For call slice in the range num calls, next call is equal to that guy. Okay. That messed that up a little bit. Hang on. Call slice. No, I don't want to. Okay, should be good. Wait, what? I swear I just did this 2 seconds ago. Why can't I just find and replace? Why is it not working? My eyeballs hurt. Call slice. Call slice. At least we'll keep it highlighted. Call slice. Call slice. Alright. So for color slice in this thing, next column is that guy. For val in next call. Oh. Wait, what? Oh my god, oh my god, oh my god. For val in next call, top thingy, bottom thingy. If top sum is equal to bottom sum, then return true. Elif top sum minus bottom true is in ht left. If call slice is equal to 0, if grid, okay, this is where things get awkward. If grid at 0, 0 is equal to top sum, or grid at the 0th column, but the m-1th element, if the 0, if the first element in the m-1th row, the very last column, is equal to this value, or so this is on the right side, so it's the very last column, but it's the, oh, is that correct? I guess so. It's like it's the bottom corner, right? Bottom right corner. Okay, if that's equal to bottom right, then return true. Continue. Okay. Else return true, and if you get through this entire thing, if you get through all the col slices and all the row slices, I forgot to do this, return false if you weren't able to do it. Okay, and so if I just ignore everything I wrote above, all I think I have to do is return self.row slices at grid or self col slices. I think I've smashed it. Nope, never mind. Oh, I'm very silly. You know what? I'm lazy. M equals numbers. You gotta, sometimes, you just gotta be a little bit stupid. Just a little bit, not loads. Damn it. Wow, it's like very specifically doing the exact opposite. Wait, how did you fail that? That's like not even, oh my god. That doesn't even need the hash table thing. That's just, okay, something severely wrong has happened. In the row slices, as soon as this should have run because, oh, don't make me print. Oh, print row slice equals row slice top sum equals top sum and bottom sum equals. It is sort of possible that I said like bot sum or something in places as well. This should be num cols, shouldn't it? If the number of columns minus 2 is equal to col slice, meaning that we have that many columns plus 1 or something. Wait. 1, 2, 3, I have 4 columns. This would be the 0th one second col slice. So 1, 2, 3, 4 minus 2. Yep, sorry. This is getting really out of hand. Okay, so what's the okay, so bottom sum was given as total sum minus top sum. So total sum is wrong. Oh my god. Row. Alright, let me print. Let me print the row prefix sum. Row prefix sum. It should look like 5 and then 10. And then I'll also say, sorry, and then I'll say total sum equals total sum. So basically what I'm expecting based on this is total sum added to 5, which indicates that maybe, yeah, okay. row prefix sum at 0. Oh, because I'm really dumb. Of course it's because sorry, it should be I minus 1, not just minus 1. In my mind it was in my mind I was stupid basically. It should just be I minus, because I did list comprehension, so at the end there's a 0. There's always a 0 at the end. Any better? Sorry. C minus 1. This is getting annoying. Let's try that. Alright. I like halfback it. I think the logic is fine. I'm just kind of sleepy, so I'm like not fully, a bit out of it to be honest. I mean, I copy and paste the whole function twice. Like, if that's not a slight sign of insanity, I don't know what is. Oh, damn it. Oh, 1 row. I should normally test that stuff, but I forgot. List index is out of range. Yeah, so like handle the test. So let me look at the constraints again. I kind of forgot to do this part. So, if num rows is equal to 1, then return false, I think. It's like an early exit. If num cols is equal to 1, then return false. Because you can't do a col slice if, you know. But in my code, I assumed I had at least 2 of everything, so I failed that. Let me just get that back. Oh, okay, never mind. That's not the reason. Oh, it tried to... Oh, okay. Sorry, it was in the col slice, I didn't realize. It probably handled it fine, actually, because it probably knew that the number of... Yeah, like this would have been 0 anyway. Okay, so sorry. Total sum is equal to col prefix at sum minus 1. Col slice in num cols minus 1. Grid at col slice. So the next col... For value in next column, you adjust. So you're adjusting the hash tables. Okay. So why did this fail if... Oh my god. Obviously this failed. Is equal to... Okay, so I have to be a bit clever. It's equal to everything in this column in col slice. So grid r col slice for r in range num rows. This wasn't accurate at all. It was like, I just tried to... Oh, I'm going to have an acceptance rate of like 6% because I'm going to be like spamming between the two. We're close though, 4 left, 5 left. 10, 5, 4, 5. Got true, return false. Why did it return true? I'd expect it to return false when it should be true, not true when it should be false. What did it find? I don't even see anything where it's close. Wait, 10 versus 14. Oh wait, okay, so it probably found that 10 versus 545 and thought it could delete the 4. So the col slicing, like, this check didn't work. So I'm going to print, I'm guessing it's here, print col slice equals col slice works. Wait, did I click use scripts? I don't think I did. Try that again. Sorry. What? Oh, so it wasn't even here. Okay, I have to go to all the... It's one row, right? So there's no way there should be any row slices. So I'm gonna just make sure print shouldn't have any row slices. I mean, I have early exit anyway, but yeah, like that shouldn't happen in this case. And then where all the places are, okay. Print col slice without any modification. Bottom corner removal. House. With some removal. Okay, I think I've got all the... Some top removal. Top removal. With some top corner removal. Col slice equals 0 with some removal. Okay, so yeah, it saw this and went, hey, there's a 4. If cols... Hang on, wait a minute. Oh, wait. No, wait, what? Oh, it's like a whole extra case, yeah. Hang on. This wasn't just like a accidental bug, this was like a genuine miss. Like, I missed this. 10, 5, 4, 5. This idea of like removing this, my code thinks this is legal. It doesn't recognize that this is like a 1 by something shape. Oh my god, wait, so what do I have to do to detect that? 5, 4, 5. So it's like, it's the fact that the number of rows is equal to 1, because normally when you're doing num-cols, you'd have like a second row at least, right? So you wouldn't have you wouldn't have a 1 by something shape. But here, you have a 1 by something shape, not because of where you cut, because like there's 3 things on this side, there shouldn't be a problem, but you only have 1 row. Oh my goodness. So if the col slice is equal to 0, meaning that you have to check oh my god, sorry. This code's gotten too confusing for me. I might have to restart, to be honest, because I think I've completely messed this up. Oops. Don't do that. Oh, it's because of my pen. HT left barrel is equal to 1 plus HT left barrel. With col slice, if bottom sum Have I been calling it bottom sum and stuff the whole time? Yeah, I have. It should be left and right sum now, but it's fine, whatever. So in this case, right sum, which is 14, will be bigger than left sum. So yeah, this runs. It's not this. You're not on the very last column like this. So it thinks that it's safe, but it's not safe. So what am I trying to say? If it's in the very last column, I think, yeah, elif num rows is equal to 1, then you still have to be careful. Oops, sorry. You have to say if, so you're going to try to remove from the bottom. So we're removing from here. If grid at this 0th row at the col slice, I think +1, like this value, is equal to that discrepancy, or grid 0th row and then n-1, yeah, like this end, n-1 is equal to, then return true, else continue. I'm gonna have to do something similar. At a 0th thing, so if at the 0th row, at the very left, if that's your value, or at the 0 row up to the col slice is the value you want, then return true. So I've got to do it 2 more times. This is genuinely like some of the most awful code I've ever written. And if the number of cols is equal to 1, then if grid at 0th column, so this is when you're deleting from the top, if first row is equal to the discrepancy, or grid at the row slice at the 0th column is equal to the discrepancy, then return true. Elif. I don't think I have to say else continue actually, I think about it, but that's alright. Just explicit, you know. Elif numcols is equal to 1, then if grid at, so we're deleting from the bottom now, so if there's 1 column, if the row slice +1 is equal to the discrepancy, or grid, or the grid at the very last row at that column is equal to that discrepancy. If the grid of this is this, and this is this. See, I don't want to just keep spamming submissions. Like, I actually want to make sure it's correct, but I'm just sleepy, man. Call slice, hit call slice works. That money modification. Are there any other cases where deletion of, like, deleting an element to make the sum is problematic? So you're doing a call slice and you try to slice something in the middle between two things. Same with the call slice, sorry, with the row slice, but you've only got one column and you try to delete something like here, and you've got two guys that get separated because of that. Alright, let me try to make a test case then with the columns, make sure. So like 10, 10, 10, and then like 15, 15, 2. So like if you get rid of the 2, that would be pretty good. False, good. But then if it was 15 and 2, then you should be able to get rid of the 2, no problem. Good, yeah. Alright, we'll see. Okay. I will, honestly, I'm going to stop for now, but I think I'm going to rewrite this because this is awful. This is generally the most useless thing I've ever done. So silly. Anyway, yeah, I'm not gonna. Yeah, we saw the zip thing yesterday. I should try that actually. I just want to see what that's like. So I think this is the unpacking operator. So grid would be unpacking into a one-dimensional thing, I think. Is that right? I think this guy went in 4 directions, is my understanding. The fact that there's 4 of them makes me think that he went down, up, like, you know how I had those arrows that went the other way? Down and up, left and right, or right and left, I mean. I think that's what he did. Fair enough. So that's fair, that's cool. Hash table or no? Set, yeah, so he used this, so he had like my first idea using sets, but then I was like, I think I can do it in one go. And then doing it in one go blew it up like that. So, alright, I'll stop it for now, but I think I can rewrite it. I'm just gonna get some food.